Hello, welcome to Data Center Knowledge FastChat, sponsored by Legrand Data Power and Control. I'm Rebecca Harold, CEO of Privacy and Security Brainiac SaaS Services and of the Privacy Professor Consultancy. You know, I started my career as a systems engineer at a large corporation, and I know the significant need for having a secure PDU that not only meets as close to 100% uptime as possible to meet business goals, but also one that can also help to detect potential cyber attacks, as well as protect data integrity and support various compliance requirements. Our guest today is Sven Anderson, CTO from Legrand Data Power and Control Division. Welcome, Sven.
Yeah, thanks, Rebecca. Thanks for the nice introduction.
I thought we'd start by just covering about when it comes to power management. What are the most common pain points that data center and facility managers face when they're selecting a PDU for their data center?
Well, I think product reliability, sufficient power density, cybersecurity, and in general, state-of-the-art PDU product features are still the main criteria when data center operators are selecting the PDU of choice. However, over the last 12 months, long delivery times have certainly been the main pain points for most of our customers. And the whole industry did suffer from supply chain issues, and so did we at Legrand. But this issue also taught us how to overcome this problem and eventually become more independent from individual silicon vendors. Modular hardware design concepts, for instance, are now allowing us to use dual sourcing strategies for various critical electronic components in our existing PDUs and also in the PDUs that we are planning to release soon. So this has, of course, created extra operations efforts for us, but this strategy will give our customers more buying confidence, and it will differentiate Legrand from those competitors who are not able to implement redundant sourcing strategies. And I think also another pain point for our customers is the big variety of in-rack power distribution applications they have to support. So a modern PDU architecture with standardized building blocks and with flexible outlet technologies can address this issue, as a specific PDU's queue can now be used to cover a broader variety of use cases in rack cabinets in the data center. So this is very beneficial for our data center operators, as the number of different PDUs queues they have to order and to deal with can now be reduced to a minimum.
Well, it sounds like you really took the opportunity to take the challenges and use them as opportunities to provide even more capabilities and benefits. When you're you listed some of the features, but I'm wondering, what are the latest advanced features then available in PDU technology today? And what additional problems do they solve beyond those that you just mentioned?
Sure. Well, we clearly see a trend towards the usage of more standardized PDUs, which can cover a broader variety of use cases, as mentioned before. Features like high-density power outlets with the option to connect either C14 or C20 power cords are helping our customers to reduce the amount of SKUs to a minimum to deal with on a daily basis. The embedded electronics in intelligent PDUs has become much more powerful over the last 10 years. This allows PDU vendors like us to implement firmware features which were just not possible to implement on older generation PDUs. For instance, circuit breaker trip detection on a per outlet level basis, signal waveform capturing on every individual outlet, or the implementation of very accurate 0.5% energy metering are just a few examples how we can utilize these modern chipsets now. And also the energy self-consumption of modern embedded electronics inside even the largest intelligent PDUs with up to 54 outlets can now be reduced to just a few watts. In combination with modern latching relays, this addresses the need of our customers to reduce the total energy self-consumption of intelligent data center infrastructure products to its minimum. And also the network card is usually the brain of an intelligent PDU. Also for this critical building block, there's no much more powerful microprocessor technology available, which is mainly based nowadays on ARM's 32-bit or ARM's 64-bit CPU technology. And we are utilizing this compute power to run our very reliable and cybersecure firmware stack Xeros, which not only provides classical intelligent PDU features like energy metering or outlet level switching, but it also provides a feature-rich human-machine interface as well as a variety of programmable interfaces, including the latest version of the Redfish protocol for easy PDUs. And you mentioned cybersecurity earlier. This is a growing concern for our customers these days, especially in data center applications. Our customers are very concerned that their sensitive data center infrastructure could be hacked and then criminally misused. This is not a theoretical issue, as such cyber attacks took place in the past already. This was possible through unsecure firmware and critical data infrastructure products. But data center operators can now rely on cybersecurity industry standards to select a cybersecure PDU from the market. And we at Legrand are committed to test and certify new PDU firmware stacks according to these standards before we are releasing them. And we are even committed to certify our complete firmware development processes to adhere to the latest ISO 27001 Information Security Management Standard. I think only such standardized industry initiatives can help the data center industry to deal with the ever-growing cybersecurity problem.
Well, that's very good to hear. I know as someone who deals with cybersecurity and privacy every day, you need all the help with cybersecurity as you can get. Right. And with all these new types of devices that are drawing the power from an organization as well, it's nice to have both of those things being addressed when you're looking at this. Could you please explain, as you were describing that, I'm thinking about your manufacturing approach, because you mentioned that it's a little bit different than it was. Could you please explain your design and manufacturing approach and how this benefits the customer and the organization?
Yeah. Well, all of our existing and also the future PDUs are in the end based on platform architectures, similar to what the automobile industry does. And for our upcoming PDU product releases, we have implemented a new PDU platform, which is based on a combination of product features that were formerly only available in PDUs from either the brands Solartech or Raritan. So this new PDU platform is based on a common technology building blocks that are getting used in specific variations in more or less all the PDU implementations. So let me give you a hardware example to better illustrate what it means. So in order to power the internal electronics of intelligent PDUs, you have to use an embedded power supply. And the reliability of this component is extremely critical for the overall PDU reliability. For the new PDU architecture, we spent the effort to design and qualify a component, a complete new power supply module with a new 3-phase power input. And this new power supply module can still provide power to the embedded PDU electronics, even if 2 out of the 3 AC input phases are failing. And we also combined this power supply module with our new and latest generation energy metering circuitry, which can measure the total energy consumption on the AC inlet level at 0.5% metering accuracy. The very same new metering circuitry is now also being used on all of our relay modules to measure the energy consumption on every individual outlet. And only one single 32-bit microcontroller is now used to implement metering, switching, and forensics features for up to 27 outlets on a single relay module. So this high level of electronic circuit integration helped us to reduce the amount of electronic boards inside a PDU significantly. And, reducing the amount of components, or in the end, increasing the overall product reliability. And it also reduces the energy self-consumption to a minimum. So in combination with dual latching relays for outlet level switched PDUs, the new PDU architecture allows us to produce one of the most energy efficient intelligent PDUs in the market. Also, another example is our new in-field replaceable IX network controller. It's also a critical building block for our new PDU platform. It runs the latest Chorus firmware stack in version 4.0, which provides all monitoring and control features, and it also provides well-defined human and programmatic interfaces. Also, other features like environmental monitoring, access control, and asset management are supported by this powerful controller, so that it can be used as a single rack level data concentrator device for modern decent application. So in the end, to come back to your question regarding the daily operations, how we produce it, this very modular PDU architecture allows us to apply new production and test automation procedures. All building blocks are getting tested 100% before the final PDU assembly step takes place. And even the wires inside the PDUs are now getting treated as a building block. So this building block test approach ensures highest product quality outputs on an ongoing basis. And it also allows us to build PDU platform components on stock to reduce the lead time of PDU orders to a minimum. And in combination with final assembly lines in the different regions, we can also further reduce the CO2 emission footprint of our PDU production, as we only have to ship small components over longer distances instead of shipping bulky PDUs around the world.
That has to be a very great thing for a lot of organizations, especially those that have implemented their green, goals for their organization. So, energy conservation in that way seems like it would be very beneficial to them, very valuable. Where do you see the value then of your new generation, the entire PDU product series, in terms of energy efficiency and future proofing, which is really important too for the modern data center operations?
Well, let me try to start a little broader with this. So I think the ongoing worldwide inflation has led to ever increasing energy costs. And the data center industry, and especially the one in Europe, will suffer from it going forward. So this will increase a growing demand for highly energy efficient data center IT and also infrastructure equipment, especially direct PDUs with very low energy self-consumption and with very highly accurate energy metering will allow data center operators to identify the energy spendings in real time. And it will allow them to optimize the energy usage to the right amount and type of IT equipment as a result of it. Only with real-time energy measurement dashboards in place, the data center operators will be able to deal with upcoming government regulations for energy spendings and with the rising energy prices. And we believe we as Legrand can help the industry by providing new PDUs that will provide our customers reliable and future-proven hardware platform to power their IT equipment reliably and safely over a long operations time, which is also important. And it will allow them to keep their energy spendings finally under constant control.
Which is all very important. And of course, board members also love to hear that as well. Thank you, Sven, for this valuable information. I know our listeners learned a lot today from our conversation. And thank you, audience, for joining us today on FastChat. I'm Rebecca Harold from Privacy and Security Brainiacs Services and the Privacy Professor Consultancy. Please join us for our next episode of Fast Chats.
Thanks a lot.